Ever looked at that little map on your screen during a flight and seen the altitude hovering around 35,000 feet? Have you ever wondered why that specific number? Why not higher or lower? Well, it's far from random. That number is the culmination of decades of experimentation, complex calculations, and hard-earned aviation wisdom. Every single commercial flight you take is meticulously planned around it, balancing fuel efficiency, passenger comfort, turbulence avoidance, and the very limits of the jet engines themselves. Today, we're pulling back the curtain on the secret of 35,000 feet, the blend of science, engineering, and economics that makes modern air travel possible. By the end of this, you'll never look at your flight map the same way again. If you love learning about the hidden science behind everyday things, hit that subscribe button and turn on notifications. We're just getting started, uncovering the secrets above our heads. The primary reason commercial planes cruise around 35,000 feet can be summed up in one word that airlines care about more than anything else: efficiency. Operating a jet is incredibly expensive, and fuel is by far the biggest cost. These planes burn thousands of gallons every hour, so even small savings add up fast. Every design decision, every flight plan, is about squeezing as much performance as possible from every single drop of fuel. This brings us to a fundamental concept in aerodynamics: drag. Drag is simply the air resistance fighting against the airplane's motion. Think about trying to run a race through water. It's exhausting, right? Imagine running on solid ground. That's the difference between flying low and flying high. Near the ground, the air is dense and thick, creating a lot of resistance. As the plane climbs, the air thins out, the molecules get farther apart, and drag drops dramatically. At 35,000 feet, there's so much less air resistance that the engines don't have to work as hard. This translates directly into massive fuel savings. Flying lower would be like trying to swim through molasses, energy-intensive and incredibly costly. But it's not just about reducing drag. At this altitude, pilots hit a sweet spot where fuel consumption, speed, and engine performance are all perfectly optimized. Airlines have this down to a science. Even a few thousand feet higher or lower can make a measurable difference on long flights. For a long-haul international route, flying at 35,000 feet instead of say 28,000 feet, could save tens of thousands of dollars in fuel for just that one flight. If you're already fascinated by how airlines use physics to save money, do me a favor and drop a like on this video. It really helps us create more content breaking down the secrets of aviation. So, if thin air is so great for efficiency, why not just keep climbing? Why not fly at 40,000 feet or even 50,000 feet? The limiting factor is the jet engine itself. Jet engines are basically powerful air-breathing machines. They work on a simple principle: suck, squeeze, bang, blow. Air is sucked in, compressed, mixed with fuel, and ignited, and then the hot exhaust blasts out the back to create thrust. Air, specifically the oxygen in it, is the critical ingredient. As you go higher, the air gets thinner, meaning there are fewer oxygen molecules available for combustion. Eventually, you reach a point where the engines coo in, get enough oxygen to burn fuel efficiently, and generate enough thrust. This maximum height is called the aircraft's service ceiling, which for most commercial jets is around 40,000 to 45,000 feet. Flying above that is like asking an Olympic sprinter to run at the top of Mount Everest. There's just not enough oxygen to perform. So 35,000 feet is a masterful compromise, high enough to drastically reduce drag, but low enough for the engines to breathe easy and operate at peak efficiency. Flying high isn't just about efficiency, it's also about your comfort. If you've ever been on a bumpy flight, you know how much better it is when the ride is smooth. Most of the weather that causes turbulence, like storm clouds, wind shear, and unstable air masses, happens in the troposphere, the lowest layer of Earth's atmosphere. This layer extends from the ground up to about 30,000 to 40,000 feet. By cruising at 35,000 feet, pilots are literally flying above the chaos. This provides two huge benefits. First, a smoother ride for you. Fewer bumps and drops mean less stress, less motion sickness, and a much more pleasant journey. Pilots will even adjust their altitude by 1,000 feet or two just to find the calmest layer of air. Second, it's a matter of safety. While modern aircraft are built to handle turbulence, avoiding it is always the best strategy. Flying above major weather systems keeps the plane out of harm's way and gives pilots a clear view of any storms they need to navigate around, making your flights safer and more predictable. With thousands of planes in the air at any given moment, how do they all avoid colliding? This is where air traffic control, or a TC, and a clever system of flight levels come into play. Think of the sky as a massive, invisible highway system with different lanes at different altitudes. To keep things organized, eastbound flights are assigned to odd-numbered altitudes like 33,000 or 35,000 feet, while westbound flights use even-numbered altitudes like 34,000 or 36,000 feet. This simple rule automatically creates a 1,000-foot vertical separation between planes traveling in opposite directions. On top of that, there's speed separation. Slower aircraft, like smaller private planes, typically fly at lower altitudes, usually below 15,000 feet. Faster commercial jets occupy the higher express lanes between 30,000 and 40,000 feet. This creates an incredibly organized and safe system, allowing thousands of planes to crisscross the skies without incident. Let's not forget, flying at 35,000 feet means you're in an environment where humans can't survive without help. Outside the cabin, the air pressure is less than a quarter of what it is at sea level, and temperatures can plummet to a bone-chilling -60 degrees Fahrenheit. The solution is a marvel of engineering: cabin pressurization. Your airplane is essentially a sealed, pressurized tube. Bleed air is taken from the engines, cooled, and circulated throughout the cabin to maintain an internal altitude of about 6,000 to 8,000 feet of pressure your body is perfectly comfortable with. That popping sensation in your ears during takeoff and landing, that's just your body adjusting to this slight change in pressure. This bubble of life is what allows millions of people to safely travel across the globe every single day, high above the clouds. Now, that 35,000-foot number isn't set in stone. It's more of a target that varies based on the aircraft's weight, the route, and even the wind. When a plane first takes off, it's at its heaviest, loaded with fuel and passengers. To generate enough lift, it needs denser air, so it might start its cruise at a lower altitude, like 31,000 or 33,000 feet. As the flight progresses and the plane burns off thousands of pounds of fuel, it gets lighter. To stay at its most efficient altitude, pilots will perform step climbs, requesting permission from ATC to climb higher, perhaps to 35,000 feet, and then to 37,000 feet later in the flight. Lighter private jets can often fly even higher, cruising between 45,000 and 51,000 feet to take advantage of even thinner air and avoid the more congested commercial flight levels. So what does this all mean for the bottom line? Every foot of altitude is tied to cost. Flying too low means burning significantly more fuel. Encountering turbulence can lead to delays, which cost airlines millions each year. By sticking to that sweet spot around 35,000 feet, airlines save fuel, reduce wear and tear on their engines, and improve their on-time performance. Delta Airlines, for example, estimates that optimizing their cruising altitude saves them about 2% in fuel per flight. That might not sound like much, but for a single long-haul flight, that can mean thousands of dollars. Now multiply that by hundreds of flights per day, every day of the year, and the savings become absolutely astronomical. If you want a deep dive into the real cost of flying at the wrong altitude, comment "Fuel Secrets" below, and we'll make it happen. The journey to 35,000 feet is a story of technological evolution. Early commercial jets like the Boeing 777 had engines that were less powerful and less efficient, so they typically cruised at lower altitudes around 25,000 to 30,000 feet. It was on until the development of the modern high-bypass turbofan engines in the 1970s that cruising at 35,000 feet became the industry standard. These engines were a game-changer, perfectly balancing power and fuel efficiency in the thin air of high altitudes. Of course, there have been exceptions, like the supersonic Concorde, which flew at a staggering 60,000 feet. But it did so by burning an enormous amount of fuel, proving that for conventional travel, higher isn't always better. So, the next time you're 7 miles high, looking down at the clouds from your window seat, remember that your altitude is no accident. 35,000 feet isn't just a number. It's the perfect intersection of physics, safety, economics, and comfort. It's high enough to save fuel and fly over bad weather, but low enough for the engines to perform and for the cabin to be safely pressurized. That number represents the calculated compromise that makes modern long-distance air travel not just possible, but incredibly safe and routine. If you learned something new about the magic of flight today, please hit that like button, share this video with a friend who loves to travel, and subscribe for more deep dives into the science that shapes our world. Thanks for watching, and fly safe.